Okay, so let's start our discussion about rebate contracts. So we are going to study the manufacturer's optimal strategy for offering rebates contracts. The manufacturer has two options, right? For any contract, it will either induce the retailer to forecast or induce the retailer not to forecast. So the manufacturer somehow needs to decide whether he wants to induce forecasting or not. In either case, we will first find the optimal contract and then make comparisons about what the manufacturer should do to maximize his expected profit. We know in all the equilibrium, the retailer will accept the contract, or we should say the manufacturer will make the retailer willing to accept the contract. Let's define the retailer's expected profit in this way. So here, RR of SC is the retailer's expected profit under the rebate contract. If the retailer observes the signal S and choose contract QC, RC, and TC. In this case, here we have the expected profit function of the retailer. Given any unit of sold product, the retailer gets P plus RC, but the retailer needs to pay TC to the manufacturer. The quantity he can get is QC. So suppose the manufacturer wants to drive the retailer not to forecast. The manufacturer needs to offer a single contract. Let's call it Q1, BN, and TN. Okay, sorry. This should be RN. Okay, it should be the rebate. So the question is, among all those rebate contracts, among all those that induce no forecasting, which is optimal? Okay, that's our question. Now let's see how may we solve this question. By accepting this contract, okay, with no forecasting, the retailer is going to earn this. Okay, we know here NN means I do not forecast, and also I choose this contract intended for the no forecasting retailer. So that's why my profit is written in this way. However, she may also choose to forecast and then accept or reject the contract based on her signal, right? So the manufacturer wants to induce the retailer to do forecasting, but the retailer will do that decision by herself. So she would ask, if she forecasts, what's going to happen? The retailer is going to earn this. So what's this? With probability lambda, the retailer is going to observe signal H. In that case, okay, his type becomes H. In particular, random variable becomes D of H, and she will ask herself whether to accept the given contract. Okay, so that's one possibility. Another possibility is with probability 1 minus lambda, the retailer is going to observe L, and in that case, the retailer will ask whether it is beneficial to select the contract intended for the no forecasting for a retailer. Okay, so the key is that if the retailer chooses to forecast, she will get more information and she will be more able to determine whether the contract is beneficial or not. In either case, the retailer needs to pay K for forecasting, so this is her expected profit if she does forecasting. Okay, so the manufacturer is solving this problem. 3 decision variables, 2 constraints. The first one is saying that the retailer must prefer forecasting. So, prefer no forecasting. Okay, the left hand side is the profit, the expected profit when the retailer do no forecasting, and the right hand side is the expected profit when the retailer does forecasting. We need the left hand side to be larger. The other one is to ensure that the retailer will participate. Okay, and we can see that incentives are given through contracts to induce no forecasting. Here, this is just to communicate about some technical assumptions. Typically and naturally, quantity and the rebate can only be non-negative, and we typically assume that transfer can be either positive or negative. Okay, this is exactly why it is called a transfer, because the money may transfer in either direction, from the manufacturer to the retailer or from the retailer to the manufacturer. Okay, so we didn't write them down, but you know it's there. And T, without special specifications, the transfer is always positive or negative. So somehow we may solve that problem, and you see a very ugly optimal contract. Okay. In this video, I'm not going to tell you about the derivation. We may leave some of the derivation works in class. Okay. In this video, I only want to tell you what do we do, what does this paper do, and about the information, about the intuition. Okay. No, but anyway, yeah, let's read this optimal contract. This optimal contract, when you are required to induce no forecasting, this is your optimal contract. One thing we observe is that when you have different values of k, when k is in different regions, you have different optimal contracts. So that's one thing. Okay, the optimal contracts depends on k. Another thing is that even though it is very ugly, but somehow it can be found. Okay, and with this, we're going to say more about what's going to happen and our intuition about the optimal rebate contracts. Okay. Okay, so this is the summary of our contracts. First thing we observe is that a rebate encourages forecasting, and that's why no rebate should be offered. Okay, this is the case in which the manufacturer wants to induce no forecasting. So there is no reason to provide rebates. Okay, if you provide rebates, the retailer is going to prefer forecasting more, and that's why I would prefer no rebates. Also, a large quantity would encourage forecasting. Okay, so that's why Q will increase in K. Okay, K is the forecasting cost. So think it in this way: when K goes down, okay, the retailer is going to prefer forecasting more and more, and you want to discourage forecasting. So when K goes down, you need to make Q goes down. Okay, so that you have some way to discourage forecasting. Okay, mathematically we can show this part is indeed telling you that when K goes up, your quantity will also goes up, at least weekly. First, if K is large, okay, in this region, we know it's easy to induce no forecasting, right? When K is large, the retailer just do not want to do forecasting. Therefore, the manufacturer can implement the efficient quantity, or Q&I, in this case, and then capture all the surplus by the transfer. Indeed, in this case, because the retailer does not want to forecast, so the manufacturer has almost no cost to induce no forecasting. And that's why if you plug in this into the objective function back, you can see that the manufacturer gets everything. When K is moderate, it is not very hard to induce no forecasting. And in this case, the manufacturer will still capture the all surplus. However, the quantity now needs to be reduced according to the reason we just mentioned. Okay, so when K goes down, this quantity is going to be reduced. Finally, when K is small, it is indeed hard to induce no forecasting. And this is the only case that the manufacturer needs to leave some rent to the retailer. Okay, the retailer prefers to have a low forecasting cost, especially when the manufacturer wants him not to do forecasting. Okay, because the cost is so low, the manufacturer needs to give the retailer some rent, and that's observed by reducing T. Okay, so if we make this part clearer, it will be something like this. This is your K. You have two thresholds, and your quantity would be something like this. Okay, I'm not saying this part is a linear function, but anyway, you know this part is increasing. Yeah. So the retailer is advantageous when K is small. Does that make sense? No, that's true, because this is when the retailer really can threaten to do forecasting. Okay? The retailer gets no rent, typically, if there is no information asymmetry. But here the interesting is that even though the retailer does not have private information, the retailer can still get some rent. Okay? It is not because of information, it's because of the threat of obtaining private information. Because the manufacturer is somehow required to induce no forecasting. That's why this threat would work. And also the power of threat depends on K. When K is large, the threat is weak or non-credible. As a manufacturer, I don't need to worry about whether the retailer will really do the forecasting or not, because I know it's too costly for her to do that. Okay? And that's why the manufacturer is advantageous and the manufacturer can get all the surplus. But when K is small, the threat will become strong, and the manufacturer must be more generous to the retailer. Finally, we may verify that the manufacturer's expected profit will increase in K. Okay, so definitely that's true, because it will be more and more hard, and it will be harder to induce no forecasting when K is small. So when K is large, it is easier to induce no forecasting.